Okay, dear students, so now we head to another problem number 10, uh, that says, consider the language S star. Like this is a language. We know that S star is a Kleene's, we call it also as a Kleene's star. And that means it is the closure under concatenation. And we know that concatenation is nothing but, for example, if I have a string w that is equals to ab and another string w2 w1 that is equals to cd. So concatenation means w concatenated with w1, and that would be equals to ab concatenated with cd. So Kleene Star says all the what we can say number of finite strings over the language, for example over the alphabet sigma, and that is, for example, 0 comma 1. If we want to construct the sigma star, for example, it would be all the set of all the strings including the empty string, or 0 1, then 0 0, then 1 1, like 0 1 1 0, and so on. This is what all about, we can say this is all about the Kleene's theorem. So this is what we can say the Kleene Star theorem. So first, for example, if for now we turn our whole attention to the problem number 10, that says, consider the problem, a kind of a language that is S star. S star means is a language that a language is a S star, where S is equals to, if S is equals to a comma b, means S is a alphabet that is on the alphabet entries a and b. Now the question is, and this S star is the language of all the a and b, including, for example, the set of, if I construct the language this S star, that would be equals to empty string, then a comma b, a comma bb, ab comma ba, or and so on. We can say the entries with 3, like this can be constructed like a b, whatsoever the length of the positions in the string are given over there, for example. So अगर अब हम इस तरह से करें कि लेट्स से ये कोई लैंग्वेज है जिसमें हमारे पास इसमें एक एंट्रीज भी हो सकती हैं, एक से ज़्यादा हमारे पास पोजीशंस भी हो सकती हैं, जो भी हो, वी आर नॉट कंसर्न्ड अबाउट दिस ऑल द थिंग्स, बट इसमें हमने ये देखना है कि हाउ वी कैन कंस्ट्रक्ट द व्हाट वी कैन द Kleene Star language. So the question is, how many words does this language have of length 2? Means the words of length 2, we have to find out the words of length 2. So the formula to find out the words of length 2 is, like, for example, we have to find out the formula for the length 2. So if we are requiring the length 2, then but we can say that the formula for length 2 would be equal to 2 power 2. So there would be the 2 times 2 means 4 words. So the words with length 2 can be formed with 4 words, that would be containing the 4 words. In this R situation, we can say that those words would be the AA like this, BB like this, and this then AB or BA. So these are the 4 words with length 2, means these are the words with length 2. Here we would say the length of each string is 2, means 2 positions are there. So there are the total 4 words, and how to find out the number of words? That the formula would be to find out the length of the words. What we can say, there are the given the 2 length of the word is 2. So now the part 2 is how many words of length 3. For example, a b a b a like this. So the same scenario, we would use the formula 2 power n. and where n is 2 power 3, because we are requiring the length of 3, so 2 power 3 would be equals to 8. So the words that can be formed from the Kleene Star or from the S star language, that would be of length 3, like AAB, ABA, or like BBB or BBA, like these words would be the 8 words. The 8 words can be formed from this language, this alphabet S, with language L, and that L language is S star. The number 3 part of the question says how many words of length 4 can be formed, or the questions can be in generally can be asked for any number of the words. So in order to in the third part, it says how many words of length n, how many words of length n can be formed from this language. The language is L, that is S star, and it contains empty string A, B, AA, BB, AB, etc. If we want to construct the words of length n, the formula for this would be equals to, when the words, number of words with length n can be equals to 2 power n. Is from this scenario we have seen, like from this Kleene Star or from this language, we see the words with length 1 are A, B only. We can prove this by the formula 2 power n, where n is 1, because the length of this string is 1, so 2 power 1 is equal to 2. So the number of words that can be formed are A or B, so these are 2. So number of, similarly, if the words length of the string is 2, like AB, AA, BB, or BA, so we can only construct 4. With length 2, means with length 2 we can construct 2 power n, means 2 power 2 words, so that is equals to 4. With length 3, where length is equal to 3, the words, number of words can be formed 2 power 3, and that is 8, like these all the things. So for length n, the number of words can be 2 power n. So the answer of the third part is the 2 power n words can be formed from can be formed with length n. That's the answer of that question.